Hello everybody, this is Dr. Nur Batsha from University of Engineering and Technology, Peshawar. In this video, I'll be talking about power method, which is usually used for finding dominant eigenvalue of a square matrix. And in this video, my main focus will be how do we use calculator to use power method for finding eigenvalue and corresponding eigenvector. So first I'll just give some small details of power method and then how does it work, and then I'll do an example by using calculator. So as I said earlier, this is a numerical method which is used for finding the largest eigenvalue and corresponding eigenvector of the given matrix A. We know that in case of eigenvalue, if you say A is a square matrix, and we will be looking or we will be having a non-zero vector x such that Ax is equal to lambda x. That's the definition of eigenvalue and corresponding eigenvector. The lambda will be considered as our our eigenvalue, whereas x, which is obviously not equal to 0, that will be termed as eigenvector. Right. Now, how does this power method work? For the given matrix A, we first choose a non-zero vector, say x0, right? This is the initial value of it. So the step number one, what do? We multiply this matrix A with the initially taken or initial eigenvector, non-zero vector x0. Multiply this with A, you'll be getting another vector y. Let's call that y in iteration number one. In the next step, what do? We find mu1. Mu1 is basically the mth component of the given vector y, sorry. It is the mth component, and the characteristic of this mth component will be that the absolute of this term ym, that will be basically the infinity norm of y. What does this basically means? Let's suppose it means that you have to pick a numerically largest value in the given vector y. Means if we have say y that is equal to a vector 3 minus 5 and 1, so this mu1, if you find for this y, it will be the numerically largest value, which is minus 5. So we'll be taking mu1 is minus 5, whereas in case of infinity norm, that will be 5 then. So we cannot simply say that mu1 is the infinity norm of this vector y, right? Then once we have found this mu1, what will we do? We would find a scaled vector x1, and that will be normalizing or scaling the given vector, the found vector, by mu1, and that will conclude the first iteration of power method. This is the first iteration. Then we find y again. You may label that as y1, y2, y3, whatever you call it. So say y is equal to, now we will be multiplying this new obtained x1 by a from left side obviously, and then finding mu2. Mu2 will be again the mth component such that absolute of the mth component of the vector should be the infinity norm, and then we scale the vector y by mu to get x2. Do again y is equal to ax2. Now finding mu3 which will be y mth component of y, where the condition will be satisfied, and then we find x3. X3 will be what? That is again normalizing the given vector, so it is mu3, and so on. Once you conclude that after kth iteration, mu k, that will be the largest eigenvalue, whereas xk will be the corresponding eigenvector. Right, so altogether matrix A will be given, right, and you will choose, or it might be given, the initial eigenvector multiplying this matrix with the eigenvector x. You will get a vector, another vector y. Then we pick numerical largest value in y, normalize y by that numerical largest value, will give you first iteration iterative value of the eigenvector. Mu1 will be the first approximation of the corresponding largest eigenvalue, and then we repeat this process. This process is known as power method. Let me explain that by using matrix, by using the calculator for a specific matrix. Okay, so let's have a matrix like that using power method to find the dominant eigenvalue of and corresponding eigenvector of the matrix A, where matrix A is given as 10, 2, 7, 1, 1, 1, minus 1, 1, and minus 3, which is obviously done through calculator, and we have found the following values. So how do we do that? I'll just explain that in a while by using calculator. So how does it work? This is the matrix A, right? This is taken as matrix A. This is obviously x0 or whatever you call it, z or something, right? So first step, we multiply this matrix with this vector. So if you do that, it can be done easily. 10, 2, 7, 1, 1, 1, minus 1, 1, minus 3, and multiplied by the vector 3, 1, 1. If you multiply this, what happens? It is 10 into 3, 30, plus 2 plus 7. Then we have 3 plus 1 plus 1. Then we have minus 1, minus 3 plus 1 minus 3. When you simplify it, that gives you 39, 5, and minus 5, which is this vector. And then we pick numerically largest value. In this case, we will call that mu1, and you see mu1 in this case is our 39, so it is 39. Then this is our x1, or you may call xz1, and that is found as dividing this vector by 39. So if you divide this by 39, you get 1 here, and 5 divided by 39 give you 0.1282, and dividing this vector by 39 will give you this quantity. Next time we will be just replacing this vector, this one, with this one. That will be replaced here, 1.1282 minus 0.1282, and multiplying them together to get this vector, picking the numerically largest value, normalizing this vector to get this one, next time multiplying this vector with the matrix, and so on. Once we have concluded, so this is the sixth iteration. So this is our largest eigenvalue lambda, which is correct up to 1dp, because you see the first decimal number is started repeating, and so on. Now, how do we do this multiplication by using calculator? That's obviously a challenging task, because multiplying a matrix with a vector is not easy job to be done. Through calculator, it can be done very easily. So let me do that. Okay, so step number 1, you have to change the mode of calculator to matrix mode. If it's not the matrix mode, that's a math mode at the moment. So I'll just press mode, and then I'll press 6 to get the matrix mode. I'll be calling this matrix as my matrix A. So I'll just press 1 to define a matrix A, and it is 3 cross 3. So I'll just press 1 to get a 3 cross 3 matrix. Now I'll put the value here. The first value is 10, so I'll just put 10. Then the next is 2, next is 7. Then we have 1, 1, and 1. Then we have minus 1. Then we have 1, and we have minus 3. So we have already input the matrix in the calculator. So just press AC because this matrix is stored as mat A. Then I will just go to have matrix B, or whatever you call it. So this is 311. So I'll just go to shift. It's a different way to input the next matrix. So shift and then press 4, and then we go for 2, not this one 4 or 5 or 3. We just go for 2 because we have to give some new data. So press 2. I'm interested in matrix B. You can call it C as well. So I just press 2. I'll be having a 3 cross 1 order, so I'll just press 3 again. The initial vector we have taken is 3. That's 1 and 1. That's done as well. Now we will be multiplying this matrix with this one. This matrix was called as matrix A, and this was called at mat B. So I'll just go to shift 4. Then I'll just call 3 multiplied by again shift this one, and then mat B, that is 4. So I'll get the first vector, that is 3, 39, 5, and minus 5. The maximum value is 39. You have to note that down. So the maximum value is 39 in this vector. So dividing this vector by 39, how can we do that? We simply press this key, division key, and divide by 39. So it will give us the first approximation of eigenvector, which is obviously this one. You see 1.1282 and minus 0.1282. Next time we will multiply this with this vector. So you don't need to input this one. This matrix is always stored. This matrix is also stored, but that is stored with what? With mat answer. So we do what? We simply press this key, multiplication key, and as you see we are multiplying matrix A from the left. So I'll just go to left and insert that matrix by using same method, shift 4, and then mat A, which is 3. So I'll just press equal here to get the next value, this one. You see 9.359897 and so on. So we can just round it off up to 4 decimal places. So dividing this by what? Now the maximum value is this one, 9.35897. So I'll just divide this vector, which is saved as mat ans, by this one. So I'll just divide by 9.358 and 7 something, but anyway it's okay up to 4 dp, and then press equal. So I'll get, you see, it's almost 1 because of the number of decimal places we have taken. And the next one is you see that it's 0.1068. The next one is minus 0.0521. So that's concluding the second iteration. For third iteration, what did I do? I simply multiply by what? Again deleting this multiplication because we multiply this quantity by mat A from the left. So going for this one, again press 4 to get matrix A. So multiply by 3 and then press equal. We get 9.8493. That's the largest value again, 9.8493. So we divide this by simply press this division key and divide by 9.8493. Press equal to get x1 now, x3 now. This is what x3, and then again we multiply this by what? By mat A. So just delete multiplication, move to the left, again shift 4, 3, and then press equal to get the next value. And the largest value is what now? It is 9.6904. divide this vector by 9.6904 to get this vector, multiply this one again with this one by using calculator. So I hope you can do that. At the end, it is converging towards the largest eigenvalue, and this will be the corresponding eigenvector, because we have taken this one as our mu6. Mu6, after 6 iteration, we conclude that this is our largest eigenvalue, correct up to 1 dp, and that is the corresponding eigenvector. So thank you very much. See you in next video. If you have any question, just drop a message to me. I'll get back to you. Thank you and see you.